Next derivative. So if you have a function, oh man, that pen color's boring. Hold on, we can't have that. We can't have that. Let's sass it up. Hold on, let me get them all set. Just hold on. Ooh, much more better. All right, so let's say we have an expression like this. So this is a logarithmic expression. So natural log, ln stands for natural log. In pre-cal, you learned that meant the log of space e of something, okay? Now this little x over here, I want you to think of it just like you would the angle in a trig expression. It can never change. It can't work by itself. You can never do this, okay? So if you have an x underneath, oh my lord, you could never cancel those two, okay? It's not log base e times x. This is a requirement. This cannot ever stand by itself. You have to have something with it, okay? So think of it like an angle with the trig expression. And just know you can't do that here. Let me put a frown with some tears. As Raina says, you can't cry out of just one side. So there's tears out of both. Okay, so new trig definition. Natural log of x, the derivative of the natural log of x. The derivative, again, all this came from that proof of using that f of x plus h minus f of x over h, okay? And when they did that, they discovered that the derivative of a natural log is 1 over whatever that expression was, okay, times the derivative of whatever was there. Okay, I know that doesn't make much sense, but let's do an example. Okay, that's the derivative. That's what you got to memorize. So if our function is a little bit sassier, like let's say we have the natural log of 5x, okay, and we want the derivative would be 1 over 5x times the derivative of this little expression right here that works kind of like an angle and trig. The derivative of that is 5. So you get 5 over 5x, and those cancel, and you get 1 over x. Okay, so the natural log of 5x is equal to 1 over x. Coincidentally, same thing as the derivative of regular 5x. It's just funky like that. All right, let's do some more examples. Okay. F of x. Let's say we have the natural log. Oh, I know. Let's just get crazy fast. Let's get crazy fast. Cosine. And let's say your angle is the natural log of x. All right, so we have a trig expression. The angle is the natural log of x, and we want the derivative of this. Okay, deep breath. Don't panic. Derivative of cosine is negative sine. Never change the angle. If you had natural log in your original angle, you have to have natural log in your derivative angle. All right, that's the derivative, but I have to do times the derivative of that angle. The derivative of natural log of x is 1 over x. So my cleanup goes like this. I have the sine, negative sine. My angle is natural log of x. All that's on top. And I have this x on the bottom. And that's my derivative there. It's kind of funky, right? Okay, let's try... let's do this. Now, some of this you kind of have to know your laws of exponents from pre-cal. So if you don't, you can kind of catch up. You're going to have to soak it in. Let's say I have the natural log of something with the square root, like 3x minus 2. Okay, so I have the natural log of that radical. Now we know in calculus we don't work with radicals, so we're going to change that to exponent notation. Okay, now one of your rules of logs that you learned in pre-cal is if you have a log expression and that has an exponent attached to it, you can bring that exponent forward. Okay, it has to do with raising a power to a power. You actually just multiply exponents, but that's your rule of exponents you learned a long time ago. So that little 1/2 is going to be rewritten in front. So I have 1/2 natural log of 3x minus 2 now. Okay, all that's your rewrite. You haven't done any derivatives yet, you're just rewriting. Okay, the first rewrite is just using my laws of exponents. The second one is using my rules of logarithms. And again, if you have a log expression like log of x squared, log base 10 of x squared, then that's the same thing as 2 times log base 10 of x. Okay, so that's just a rule. Okay, let's continue where we are. All right, so now I still want to do the derivative. I haven't done the derivative. All I've been doing is concentrating on the rewrite. This is not product rule because it's not a variable times another variable. It's just 1/2 as a coefficient. Okay, so that makes my life easier. I don't have to worry about it. When I take the derivative, it just kind of goes along for the ride. All right, so 1/2 times. The derivative of any natural log is 1 over whatever that angle type expression is, okay, times the derivative of what was inside the parentheses, which would be 3. And when I put all that together, I have 3 over 2 times this 3x minus 2. Ice cream man. Ice cream man. All right, we gotta hurry this up. Distribute that 2, 3 over 6x minus 4. That's your derivative. And I'm going to put a little dx. So that's kind of interesting. It's different. All right, let me try one more example for you before I let this video go. Let's do green. You feel green? I feel green. I'm looking at the book here. Oh, I don't know. They're all basic. You guys are too good for these. All right, we'll do one more. So, okay, f of x equals the natural log of x cubed. Okay, so this time your little angle thing or what's attached to the natural log is just plain x, but the whole log expression is being cubed. So this is not a case where you can bring that 3 forward. Okay, there's a difference between this and this. Okay, and in the second expression, you have this times itself 3 times. Okay, and that's different than just the fact that you want the natural log, which is really asking for an exponent of x cubed. Okay, so this is not a case where you can bring that 3 forward, just like the rule above. All right, again, because of the difference between these two. So this one, though, if I want the derivative, this is when I have chain rule. Bring that 3 forward. So this is derivative times the natural log of x. Subtract 1 from my exponent, I get 2. Times the derivative of what's inside. The derivative of natural log is 1 over x. The derivative of that little x is 1, so I don't have to worry about it. So I have 3 times the natural log of x squared over x. And that is my answer.